Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques. In this video, we're going to take a look at how to calculate confidence intervals in the world of statistics. So why don't we go ahead and get started on this. So when you are trying to calculate confidence intervals, what you are trying to figure out is within what range or within what interval can I expect the population mean to be based off of a given sample. So basically what's happening, if I had to draw you a picture, is you have your distribution, your normal distribution like so, and of course, you know, your mean should be, your sample mean should be somewhere about in the middle. And what's happening when you do a confidence interval is that excluding, if you will, the rejection zone. I'm assuming you're familiar with, you know, what do you call it? You know, hypothesis testing. You're excluding the rejection zone right here, these two tails. Now this is not drawn to scale, obviously. And so essentially what the confidence interval is it is this range in the middle where you expect the population mean to be somewhere in the middle. So what's happening here, and I'm going to explain more in detail in a second, is that if you clip off the ends of your distribution, you expect the population mean to be somewhere in the middle. And that if you were to resample over and over and over again and keep resampling, most of the time you will find out that the actual population mean was somewhere within this little range where the orange is at. Now, when you want to calculate the confidence interval, there's several pieces of information that you need. Number one, there's no particular order here. You need the sample size, so you need your N. Another thing that you need is you also need to have your sample mean, your X bar. Also, you got to know your sample standard deviation, the S, if you will. You also need to determine something called the alpha. The alpha, like I told you, is setting up your significance level. So what's happening here is that when you go back to our distribution here, this whole section here from one end all the way to the other should come to the value of 1. And what's happening with the alpha is trying to determine what the rejection area is. So normally the alpha can be several different values, but for our purposes here, the alpha is always going to be 0.05. How do you get that? You take 1 minus 0.95, and then you get 0.05. This is our alpha right here. The 0.05. In other words, what I'm doing here is that I'm excluding 5% of the values, the lowest 2.5% and the highest 2.5%. That's what I'm doing, because what I'm saying is that that's extreme. I want to have a 95% confidence. That's where this comes from right here, this decimal 0.95. That's what we're doing here. And so by excluding these, you're able to create an interval. That's what you're trying to do, because if every number if you have the whole range is 100%, there's no confidence when the mean can be any value. But if you cut off the tails, you can limit the potential values that the population mean can be. Now, why do we divide it by 2? Because when we subtract this 0.95, we get this number here. But we don't have only one tail, we have 2 tails. That's why you take the 0.05, if you will. You take the 0.05 and you divide it by 2, and you get 0.025, if you will. Now, the last thing we have to do with the alpha is that you have to convert that to the z-score, which in our case is going to be 1.96 when we get to the actual problem. This will make more sense when we go over the actual problem in a few minutes. The z-score can be found when you look at z-tables online or whatever in case it might be. So these are the pieces of information that we need to be successful. And let's just review this to make sure it's clear, because we've covered a lot of material. So you must know your sample size. We've talked about that. You must know your sample mean. We've talked about this. You must know your sample standard deviation. We've talked about that. We must know our alpha, and our alpha was taken from taking 1. That's the whole range of the distribution right here, this 1 minus 0.95, you get the 0.05. But we're not done yet, because we don't have one tail, we have 2 tails. So we have to divide that number by 2 and we get 0.025. This number right here must be converted to a z-score, and it's going to be 1.96. So basically what's happening here is that any value that is 1.96 standard deviation above the mean is rejected. Also, any value below negative 1.96 is also rejected. So I should put the little positive minus sign right there. That's what's happening, and this is very, very important. Again, the details around the alpha can be found in, resources online. Now, I now need to show you the actual equation or expression, if you will, that is used to calculate the z-score. Or not the z-score, but excuse me, the confidence interval. So if I go over here, I'll just show you this real quick. So we have x bar, that's it, minus our z-score, that's z-score, the alpha of it, divided by 2. And then we have the standard deviation divided by the square root of the sample size. And then we have mu, and then we repeat this process. Then we have x bar again. Running out of space here, sorry about that. Plus z-score again divided by a over 2. Let me do that one more time. A over 2, and then sorry I'm out of space here, but then you can see here. All right, so this is our interval notation. If you're familiar with algebra, you've seen something like this before, interval notation. And so we take this information, and again, we know what all this information is. This right here is our sample size. This right here is going to be our z-score that we're going to use. This right here is our standard deviation of the sample size of the sample as well, the n. And this right here is what we're trying to figure out, the population mean. We never know exactly what it is. This is why we're calculating an interval that we can have some confidence in. That's what we're trying to do here. Now, this is all the theoretical stuff that I've just explained. Let's take a look at an actual problem. So let's just say you give a quiz. You're a teacher in a class or whatever. This could happen based on a true story, and you have an N. You have 45 students, and the average score, let's say on the quiz, if you will, was 83, and the standard deviation was 9.5. Now, what we want to know is the 95% confidence interval given this information. So, since I already told you what the z-score is for 95%. In other words, and sometimes this gets confusing, but what's happened is that we're trying to measure how confident can we be in the interval. So, most of the time, the population mean will be within this given range. Technically, the probability is 95%, if you will. So, the z-score, or our ZA2, if you will, is going to be 1.96. That's what we're going to do here. Now, let's move to the next screen because we're running out of space. I'll rewrite that. So we got our n equals 45. We got a sample mean of 83. We got a standard deviation of 9.5. And we got a z-score here, 2. Well, let me do that again. Z-score here of 1.96. That's what we got. So here we go. We're going to set this up now. So the first thing is going to be the sample mean. That's going to be 83. We already know that. Minus 1.96. I hope you remember that from the previous slide. Now divided by 9.5. This is our standard deviation. Over the square root of 45. This is our sample size. Close that out. Then we got our mu. And then we got 83 this time plus 1.96 divided by times 9.5 over the square root of 45. Okay, that's what's happening. Now, if you calculate this information right here, let me see here if I can make this clear for you. If you calculate this information right here, you can do it in a calculator. I'm not going to sit here and do it for you. You will get a value of 2.77. So this value is going to be 2.77. This value right here is going to be 2.77. You can verify that. So if we had to get the actual answer now, it would be 83 minus 2.77 mu, and then it'd be 83 plus 2.77, like so. Which comes out to a final answer down here towards the bottom. Our final answer would be 80.23 and 85.77. That is our final answer. So in other words, we can have 95% confidence that the population mean, not the sample mean, but the population mean is somewhere between 80.23 down here and 85.77. So if we were to go out and to, resample over and over and resample over and over and over, we would keep finding, means that are most of the time between these two ranges. If we could actually go out and collect the actual population mean, it would probably be somewhere between these two values right here. Again, for practical reasons, we rely on confidence intervals because it is not feasible to actually calculate the actual population mean, because you have to collect information from the entire population, which is not always doable. So this gives us a very accurate, a very secure estimate that we can use going forward. But it's always going to be an interval, and that's kind of how it works out. So in this video, we looked at how to calculate the confidence interval, a very powerful tool that is used in informational statistics to help people to figure out what they can expect the population mean to be in most situations. And so on a previous slide, we looked at the equation of how this works out here. You have your sample mean, your alpha right here, times the standard deviation over the square root of the sample size, etc. That's what you use there. And so this information is very valuable. One thing that needs to be clear is that when you're dealing with the alpha, and this is something that is a little bit confusing, but the alpha is basically your rejection zone, the information that you consider extreme. So again, here's my distribution, and this is my rejection zone on the lower tail, this is my rejection zone on the higher tail, and often we exclude 0.05 or 5%. We consider that to be extreme often in statistics. There are other values for alpha, but this is what we're going to do. And so when we want a 95% confidence, what we're saying here is that we're excluding 5%. And by excluding that 5% on these two tails, you get this nice little region right here in the middle, which is the actual confidence interval. If you don't exclude something, you can't have any confidence, because if everything is possible, then there's no way to limit anything. But by saying we want to know what to expect 95% of the time, some sort of a probability, you can then get some idea of what to expect that population mean to be, which we don't know most of the time. So my name is Darren Thomas. This is Educational Research Techniques. Thank you for listening.